Here's an example about a person walking. They leave home and they walk 2 miles west and 6 miles southwest. The question is, how far from home is she, and in what direction must she walk to head directly home? Tricky one. I think it's best to draw an axis system, a little picture that'll help us out. All right, so I'm going to come over here and draw an axis system. Okay, so what does she do? She walks 2 miles west, so I'm going to make this the starting point. This is home. Right, she leaves home, walks 2 miles west, so I'll just do an arrow and say, okay, this is 2 miles west. Whoops, wasn't a very good west there. 2 miles. Remember, it's north, south, east, and west, right? She walks 2 miles west, and then 6 miles southwest. So that is 6 miles, and that is southwest. That diagonal down direction from right there, right? Diagonal down. This means this is 45 degrees. Southwest is 90 degrees would be straight down, so southwest is halfway there, 45 degrees from there. Okay. So she does those two motions. So the question is, how far is she from home, and in what direction must she walk to head back to her house? Okay, well, we can do this problem with vectors and just add those vectors up, and that'll help us figure out how to do this actual problem. Let me see, I'm thinking of vectors. Yeah, vectors would probably be the best way to do this problem. So let's do that. So I'm going to do step number 1. Find the two vectors. So the first vector, remember how you always find vectors is you always have the x value is m, cos theta m is the magnitude. The y value is, m sine theta. Again, m is the magnitude. So the first one is pretty easy, right? You can say the first vector, it's just -2, 0, right? She just goes back to the x values, back to the y values. I don't even need to use formulas. But then the second vector, I'm going to have to use some formulas for the second vector. So this vector here, I'm going to put a little axis system right here for the moment. This vector, I got to get the angle all the way to that vector from 0 degrees, remember? So the angle is, what's that going to be? That's going to be 180 plus 45, which is 225 degrees. That's from 0 degrees counterclockwise, right? That's how we measure actual angles. So 225 degrees. So that vector is 225 degrees. So the x component for that vector is going to be 6 cosine 220, and the y component is 6 sine 225. So let's crank those out on the old calculator. Make sure you're in a degree mode. I'm getting -4.2426. And for sine, I'm getting the same thing. Exactly. 2426. Okay. So there is the x and y components of that vector. So we're going to add the two vectors together to get the resultant vector. You tracking with me here? So the resultant vector will go from here to there. That right there is the resultant. It's the two vectors added up. It's the result of those two movements. So let's bring that into the game here. So the result, step 2, the resultant vector will equal the sum. It'll be the sum of the other two vectors. So I'm going to add up the other two vectors. So I'm going to take the first vector, which was minus 2, 0. Sorry, that's kind of scribbly. Minus 2, 0, and add the second vector, which is minus 4.2426, comma, minus 4.2426. So I'm going to add those up, and that will equal the x and the x. That'll be minus 6.2426. I add the x with the x, and I add the y with the y, minus 4.2426. So there's the x added to x and y added to y. So that's the resultant vector. And they're asking for us how far. So that's the length. I've got to find the length of that resultant vector. So how far equals the square root of x squared plus y squared, right? That's the formula for how you find the length of a vector. So that will be the square root of the negative 6.2426 squared plus y squared negative 4.2426 squared equals, all right, whatever my calculator says it equals. I'm getting 7.5479. So there, that's the length of the resultant vector. So that is how far she is from home. 7.547. They didn't sound many digits. That's plenty. That's how many miles she is from. See what we're doing there? I just took the first vector. She went 2 miles west, and then the second vector, 6 miles southwest. Made them vectors. Added the x and the y to get the result, right? This vector plus that vector is the resultant vector. The result of all her movements is the first vector plus the second. Here I added the first vector and the second vector, got the resultant vector, and then I took its magnitude to find out how far it is. Now the final question is, what direction does she need to head in to go home? Right here. In what direction must she, in what direction must she walk to head directly home? Well, that's a good question. How does she head directly home? Well, here's where she's at now. And I'm going to make another little axis system there. And to head directly home, I've got to find, this angle right there, don't I? I got to find that angle. Got to find that angle. How am I going to find that angle? Well, what I could do is find this angle right here. You see that? I could just find that angle right there, and I could do inverse tangent. No, I'm sorry. This is not a right triangle. What in the world am I thinking? We can't do that. We cannot do that at all. My mistake. So, yeah. So instead, what I'm going to do is I'm going to find the angle for the resultant vector, and that'll be it. Yeah. All right. So I'm going to have to find the angle of the resultant vector, which means from here all the way to there. Call that theta, and then I'll use that to help find the other one. So let's find the angle of the resultant vector. Remember how we find the angle of a resultant vector, or of any vector? Angle of a vector. How we find the angle of a vector? We take the inverse tangent of the absolute value of y over the absolute value of x, because that puts it in the first quadrant, makes it a reference angle. So we have the y and the x. Here's the y, and here's the x of the resultant vector. So it's the tangent, so we're going to do positive 4.2426 over positive 6.2426. Take the inverse tangent of that on your calculator, which I'm doing right now. And I'm getting, that angle theta is 34.2008 degrees. But remember, that is a reference angle from 0 degrees counterclockwise. It's a reference angle. So notice it's first quadrant. That's a first, why is that first quadrant? Because we made the angles positive. Right here when we did absolute value and made this positive and this positive when they were really negative to begin with, we put it in the first quadrant. Why did we do that? Well, because now the second step, so that's step A and then step B, is you find the actual angle by the quadrant. Remember how you can look that up in the notes, so we can tell that this actual vector, the resultant vector here, is in the third quadrant, isn't it? Third quadrant. So in the third quadrant, it's going to be 180 degrees plus theta. So the actual angle will be 180. So the actual angle is 180 degrees plus 34.2008 degrees, which is what, 214.2008 degrees. Right. So that's the actual angle. That means, what does that mean by actual angle? From 0 degrees, that theta is the one I just told you, 214.2008 degrees. That's from 0 degrees all the way to there. That's 214. Okay, great. So how does that help me? Well, last step, very last step, I promise it's been a long problem here. Last step, we really need to just find this angle here, which will be the same as that angle there. Why? Why are they the same? Well, do you see how they both come off this is a horizontal line and this is a horizontal line? They're both angles to the same resultant line off of horizontal. So this has to match that. They're called z-angles, alternate interior, when you study geometry. They're both coming off the same line, the resultant line, both going to horizontal. So they've got to be the same angle. Okay, great. Do I know this angle? Do I know this angle here? Yeah, because it's 180 to here, right? So this angle here has got to be, well, here, let me put it over here. This angle here has got to be the 214.2008 degrees minus the 180, doesn't it? Because it's 180 to there, right? I don't know if that's the best place to draw that. It's 180 to there, and so then the rest of the way, subtract that, is going to be, that's the 34.2008 degrees. So that must be that, and that must be that one as well. So that's how many degrees. Oh, wait a minute. Oh, man, this is a hard problem. So we think, okay, that's our answer. Almost. We're so close. They actually want north of east. Oh, yeah, no, that is it. Because this is east. This is east. This is north, south, west. That's how many degrees north of east, right? North of east. It's 34.2008 degrees north of east. Like here's pure east, and that's how much north of east. So we did get it. There we go. So what did we do? We made these two vectors. Straight west was minus 2, 0, back 2, up 0. And then southwest, we found the angle to be 225 degrees. Use the formula x is m cos theta, y is m sin theta to find that vector. So then we had the two vectors and we added them to get the resultant vector. This is the result of those two movements. You went 2 miles west, and then 6 miles southwest. The result of those two movements, we found the resultant vector by adding those two vectors up. Got it here. They asked for the magnitude of the length of that vector. That's how many miles total she traveled. And then we found the angle of the vector, and this is the part a lot of people get stuck on, is finding the angle. Remember, tangent inverse of absolute value gives you the reference angle. That's just from 0. And then you've got to go to the actual quadrant. I'd add 180, 214. So then 214 was all the way to the vector. And so we subtracted the 180, and we got just this little part right here. We subtracted 180, which is 34. It's got to be the same as right there. That's the angle north of east.